Linux In-Laws, a podcast on free Libra open source software. Broadcasting from the United Kingdom and Germany.
Welcome to Linux In-Laws, Season 2, Episode 61. Martin, how are things on this very fine autumn, winter, or spring day?
Yeah, very well, thank you. Halloween's around the corner, so something to look forward to.
Yeah, I mean, that's what I read in the press the other day. I mean, Halloween is now 2 dates. One in autumn and one in spring. Exactly. Yes, you missed that apparently.
Okay. There's hardly a day when there isn't some kind of event going on these days.
Speaking of Halloween, Martin, how is Mr. Steimer going? As in, your president. Sorry, not your president, but your man in charge over there in the UK. All right.
Starmer.
Yes, that's the name.
Yes.
So,
well, he's obviously.
You're still happy with him, I take it,
with the ghouls and people like that.
So you're still happy with him, and Charles is playing along as usual.
He doesn't have a choice, right? So.
Well, he can. I mean, in former times, these kind of people of the people, as in man of the people, could be beheaded and other stuff. I mean, I'm just talking about 500 years back, maybe 1,000 years back. There's a lovely place actually in central London called the Tower.
Oh, I thought you were thinking about France, where they
no,
a bit more seriously.
Yes, Martin. But France is only a couple of hundred years ago, and not 1,000.
Who knows?
Of course, as usual, France took a leave out of the English book in terms of what to do with politicians that do not play along. So, Charles, if you're listening, capital punishment, I'm afraid, is out of the question for the Prime Minister. Check your constitution just in case. But I think there's no constitution in place, right? In the UK.
Well, there is. Yeah, there is a constitution, but
there is. Okay.
If you mean that the royals don't have any real power.
No, Martin, this is called the common rule. No, maybe I'm wrong. But this is not a podcast about British politics, but rather about a free software.
Is it not about German politics?
No, neither. It is neither, Martin. It is neither. And with that, basically, we basically coming to tonight's topic in terms of a refresher on update on MongoDB. And for that, we have no other than Jan Goebel on the podcast, who will talk about MongoDB and related issues. But Jan, before I even get it more wrong, why don't you introduce yourself?
Thank you so much. Yeah, welcome. And thanks for having me on the show, guys. I really appreciate that. Hi, everyone. My name is Jan. I'm a solutions architect at MongoDB. So basically, my job is to talk to customers and explain to them how they can use MongoDB and how they can achieve their business goals. I work with various companies and with various accounts in various industries. At the moment, I'm more or less focused on banking and insurance because that's where I'm sort of coming from. So I have a bit of domain knowledge there. And that's pretty much what I do. And again, thank you so much for the invite.
No problem. Before we go further, I mean, we already had MongoDB on the show about 3 years ago. A guy called Joe Drumgoole was kind enough to share an update. But before we catch up on the Delta, why don't you tell the audience, as in the two members of the audience who do not have a clue of what MongoDB is, what this database is, and how it fits into the overall SQL, NoSQL, IMS, DB2 space.
That sounds like a great idea. So basically, MongoDB is a document database. The idea here is that if you consider like a relational database, you store data in tables, right? You have a relational format, then you have your tables, and then you then you join the tables together. And MongoDB does things a little bit differently. So with MongoDB, you actually store objects. And the fundamental difference between, how MongoDB works and like how a relational database works is that we say data that is accessed together should be stored together. So everything that you want to access should ideally be in one object so that the read that you actually perform is really, really fast. So in other words, you just save yourself a join. And this is the reason why MongoDB is very well suited for really large scale applications. So really gigantic scale. This is also where the name comes from. So the name originally comes from humongous, so like gigantic, and it came originally from an ad context. So initially the idea was to just build a platform to serve ads back in 2007. And turns out ads were quite a big thing back then. And you literally had like billions of impressions per day. And that was just very hard and very difficult to manage. So you needed like a different database, something that can scale. Yeah, MongoDB is very good at scaling horizontally. It is really from the very start designed or thought of as a distributed system. And this is basically how MongoDB got started. And then initially, when MongoDB was built, people figured out, hey, actually, this is much more than an ad platform. And then basically the company pivoted, and this is what we call MongoDB today. So that's basically the whole story in a nutshell. There's many nuances and differences and, details about how it's different from relational databases. Can give you more details, but don't want to make my initial answer too long.
It's sometimes considered as the lazy developers database, right?
Pretty much, yeah.
Shove everything in a document and away you go.
Exactly. So the idea also, or the philosophy behind it is that it should be as easy to store data for a developer as it is to write the code. So you don't have this abstraction layer in your code base that, you have your classes, you have your objects, and then you have your ORM, and then you have some strange set of tables that is super large, and then you have to remember what each table is doing, and then you have to join it together and all of that. So you don't have that complexity anymore. And generally speaking, you're totally right. This leads to much simpler data model. And this is the reason why what we see in practice is that you can develop much faster. So changing things, adding new things, adding additional functionality on top, also catering for the different nature of data. Right, so most data is actually unstructured. You just can't fit most things on an Excel sheet, right? And if we are honest, like a relational database is kind of similar to like an Excel sheet with a bit more advanced algorithms and joining. But with MongoDB, we actually support something called polymorphic data. So the idea here is that each record can actually look different, and that all of this is supported like anyway. So you can basically cater for the fact that the world is a messy place and that not everything can fit in a perfectly structured table.
Interesting perspective, because we're going to touch upon that, I reckon, in more detail in a moment. But when I take a look at the history of MongoDB, it has changed a lot from being an original document database to a much more multi-model database, especially with the event of time series and vector functionality and all the rest of it. But setting aside these multi-model or multi-type databases, if we're talking about scalability, of course, Apache Spark and Friends come to mind in terms of data lake architectures, given the fact that there's a significant competition out there. Do you see Mongo fitting into that space, or do you want to keep it still to a kind of more multi-model approach when it comes down to database functionality as such?
Yeah, so I would see the sweet spot of MongoDB in high velocity, high throughput OLTP applications. Like that's really where MongoDB is really excellent.
You may want to unpack these terms for our non-database listeners.
Yeah, sure. So basically, OLTP means that whenever I have an interaction with the database, I touch maybe one record or a small amount of records. So you can think about, let's say you go to an e-commerce store, you make like an order and so on. You don't order the entire store, right? Or you don't compute any complex aggregates. This is what OLTP is. So think about making a purchase online in an e-commerce store, creating a user, creating a ticket, like these kind of things, they are all OLTP. The opposite of OLTP, so OLTP stands for Online Transactional Processing, is OLAP, so Online Analytical Processing. So this is more the idea of I have huge amounts of data and I want to compute some complex aggregates over it, right? So basically, I want to know what is the average median, what are certain values of window functions and so on. So the classical analytics, right? I have 20 terabyte of data and then I compute something. And the sweet spot of MongoDB is really in this OLTP case. So really lots of transactions, like many small interactions with the database. This is like where MongoDB is really, really good. Simply because you store the data together in one thing that we call document. And because of that, writing and retrieving the data is very, very efficient. And this is where I would see the sweet spot of MongoDB. So we specifically say that we ourselves are not a data warehouse. Right? If you want to do something with data warehouse, go talk to Snowflake, Databricks. But like pure analytic use cases where you analyze 100 terabyte of data, this is not really what MongoDB is made for, simply because you can't leverage the advantages of the document model. So the advantage of the document model is that your data can actually look differently, right? You can have different fields. As I said, data is messy and so on. Whereas if you want to do analytics, you basically have some sort of ETL process where you bring everything into the same format. And that's why MongoDB is more suited for OLTP workloads. You can do analytics with it, like real-time analytics and so on. But if your only use case is, I only want to do analytics, then MongoDB is not the right platform for you.
Interesting perspective. We had Joe Drumgoole on the show about 3 years ago. I think it was season 1, episode 90. Links may, of course, be in the show notes. Give us a kind of short overview of what happened since, especially when it comes down to version 7 and 8 of MongoDB with regards to what has entered the community codebase. And when I say community codebase, I mean the stuff that is available on GitHub. I'm not talking about the enterprise feature now because this is not a sales or marketing show, but rather a Flots podcast focusing on free libre open source software. So what are the main benefits of versions 7 and 8 with regards to the
before
Martin?
you do that, sorry, I wanted to ask one question on the previous discussion.
Oh, Martin, go ahead.
You mentioned the likes of Snowflake, right, and data warehousing, stuff like that. Now we've seen Snowflakes and Databricks, they're all moving in the opposite direction, as in adopting OLTP technologies. Is MongoDB planning to do something similar in the opposite direction, as far as you know?
Yeah, I'm not aware of any like direct initiatives in that regard. So I think the focus of Mongo has always been very clear. So it's more like on the OLTP level, and also what we discussed before, right? That over time we actually added lots of new functionality. So initially, what we started out with the core database. So basic CRUD operations and so on. And then we realized that people need some additional functionality because they're just common. And now we come to what we actually changed in version 7. So what we noticed is that lots of people are actually or need different functionality, and they just use special purpose databases for it. And the idea of Mongo was then to say, we want to support additional things. So for example, in version 7, we also added the support for time series, also in the community version. So that is really great. This allows you to basically store tick data of sensors of, IoT you have at home. Let's say you have a solar panel installation at home, or like some sensors, or like a smart home. You could basically store all those sensor values efficiently, simply because internally it buckets the value together, and then it needs less storage. So the storage savings they are really, really significant when it comes to that. On top of that, what we also did in version 7, we introduced some additional security features. So this was always something that people wanted. So when you use the database, you typically have the encryption at rest, right? So the storage is encrypted. Then you have the encryption in transit, hopefully. So you use TLS and so on. But the data is actually decrypted when you load it from the disk in memory. And what we added as a capability is basically you can now encrypt your data end to end. And this is what we call queryable encryption. So you're basically able to encrypt your data on the client side. And then you can be sure that throughout the entire journey, so throughout the network, into the RAM of the database, and then to the storage, the data is encrypted. Thereby you can basically create fully end-to-end end-to-end security or fully end-to-end encrypted systems. This is especially interesting for people who are very into security and very privacy aware. So I would say these are the main features that came in 7 and 8. 8 was also a very big refactoring internally when it comes to performance. So the whole structures and the way that memory management is handled and so on was like a massively improved. So if you just upgrade from, let's say, a previous version to 8, you will feel like a noticeable performance improvement. So under the hood, we did a lot of rewiring and making sure that this is basically the fastest release we've put out so far.
Yeah, no, I mean, you mentioned OLTP, right? And we briefly mentioned Snowflake and Databricks adopting OLTP. Obviously, the one main database that springs to mind these days in OLTP is Postgres. How do you guys see that in your daily life? Is that really something that, we've seen the rise of Postgres in popularity in the last few years, even more than before. Is that something that you guys are thinking about? Do you see it much in your daily life? That's kind of...
Yeah, I actually see that a lot. So I would say these days, at least with the accounts and the companies I work with, Postgres seems to be like the thing that people might think first when they come up with a new application. I think there's a bunch of reasons for that. The thing is just that it's a relational database, and relational databases have been around since the 1970s. All of that stuff is basically taught in college and in school, so everybody's aware of it. And then, of course, it's also free and open source, and, there's various different flavors of it. So this is something I see a lot. And people, that's actually the main discussions that we frequently have is, okay, why should we use Mongo? Why should we not use like Postgres or like some other relational database? Like, what material benefit do I get if I basically go for MongoDB instead of Postgres? And it, of course, always depends like on the particular use case. One thing that we frequently see, and this is something that is more or less based on all the opportunities I've seen, is oftentimes when people think about the project that they're building, they're thinking about the next deadline they have, right? They know, okay, I need to deliver version 1 in Q1 next year, and that's the only thing I care about. And I often then ask them, okay, but what about version 2 and version 3? Because typically complexity increases, right? You add more and more things. There's more exceptions. There's more like extra things you add on top. As I said, the world is a messy place, so there's a few fields here and a few fields there. And you can see that after a while, so after a few iterations, the complexity of the application increases significantly. And this is what we often see. But we also see that oftentimes people don't think about version 2, 3, 4, and 5. And this is oftentimes where like we as MongoDB come in and say, hey, look, what other things do you want to build in the future? How does your target data model look like? I talk with customers, they say we have 250 tables. And I ask them, hey, look, if I were to randomly pick out a table, can you tell me what this table is doing? And then sometimes people are confused, say, maybe if you pick like one of the main tables, maybe. But I said, okay, look, like, how long have you been working here for like, and then I get the answer, okay, 4 or 5 years, and say, okay, look, if you don't know it, how should someone who joins the company know it? Right, so the complexity over time just adds up. That is one thing we observe, and this is something that people usually don't think about. So that's one part, and then there's of course also functional differences. So there's really strong functional differences when it comes to what MongoDB can do and what JSON-B can do. So JSON-B basically allows you to store JSON in a Postgres column, but there are like quite a few differences. I can elaborate on a lot of them if you want. but like I can mention a few. So for example, if your document that you're storing is larger than 2 kilobytes, what Postgres does is it moves it out of line. So this is called toast. So the document is basically so big, it gets moved to a separate table. And once that happens, you get a massive drop in performance. And this is sometimes something that people don't think about, right? This is only something you notice once you have your system running in production, and then you have a bit of traffic on it. And then you realize, oh, yeah, maybe there's a limitation here and there. And this is basically where we support. Yeah, so we come in and we ask some questions, and then we see if Mongo is a fit. And maybe it is, and maybe it's not. And this is basically my day-to-day task, I would say.
Yeah, very good. I mean, that's clearly, from a technical point of view, very interesting. For those people not familiar with the workings of Postgres. But yeah, that's a good point about the toast tables. There are, of course, also other open source alternatives coming up the last few years, like, I don't know, the FaraDB being one of them, for example. Is there much that you're... I guess, first of all, these are quite new, right? So they're going to be technically quite different from MongoDB. But how are you seeing the rise of the multiple, let's say, document databases that's happening in open source land out there?
Yeah, I mean, we can definitely see that, more and more databases are coming up. I mean, the overall like database landscape in itself is very diverse, right? There's like hundreds of, probably thousands, maybe, I don't know, databases that are out there. For me, the main question is always like, how's the community like? And I think this is something where MongoDB can really shine, also because of its open source, or like because of the community offering that we have. So we have a very large community. If you look at, Stack Overflow surveys, hey, what are the most popular databases? We're pretty much always at the top 5, or at least like top 10. Usually when you ask people about like NoSQL databases, then we're also at the very top. So I think this is what makes the database really effective and good, right? So you need a community, you need people who use the database, people who bring in new features, new ideas, you need content, right?
And just to barge in here, I thought Redis was the most loved database on the planet. Or did that change?
Yeah, that's sort of what all databases say about themselves, yeah.
No, I'm just joking, of course. People, if you do not know what I'm talking about, please go back to the back catalog.
No, that's totally fine. I mean, the question is also not so much who is basically number one or who's number two. The question is more like who is top of mind with the developers, right? If you ask a developer, hey, what NoSQL databases can you think of? Okay, they will probably mention Mongo, they will probably mention Redis, maybe some people will mention Dynamo and so on. I think it's important that you are in that area, right? You ask people, they know your name, right? They know the database, and then they're also more will to sort of consider, hey, maybe that works or maybe that's a good idea for my next project. But yeah, I mean, overall databases, there's many opinions and many vendors. Yeah. So depending on who you ask, you're going to get different answers. Indeed. Yeah.
Well, this is why the surveys like Stack Overflow and things like that. And but yeah, surely if you're running a race, you want to be first, right? But let's not go there. I was going to ask, you talk about community, right? So what about the actual the maintainers of open source MongoDB? How's that community looking like?
Yeah, so I would say the community overall is very open. So we also encourage people to make PRs, especially also on not just the core database, but also on other things, right? We have lots of drivers, for example. We also have lots of additional tooling that lives besides Mongo that you just need. So this is always like a place where PRs are welcome. When it comes to the core database, of course, the PR reviews and the contribution guidelines are a bit stricter, right? Because we need to make sure that the database performs well, that it's still functionally correct, that it doesn't get any slower and so on. But if you think about, hey, I'm using the C# driver, and I want to have like some functionality. I'm missing some functionality in there. Yeah, I mean, you can make like a pull request, right? And then hopefully your PR gets merged, and then you contributed something. So I think that's really a great concept.
Interesting perspective there, because that nicely leads. I mean, the whole code base is I'm talking about the server now. The whole code base is licensed under server-side source code available license model, like SSPL or whatever it's called these days. That means if you want to contribute to the server side, you have to sign in a CLA as a contributor license agreement.
I'm not aware that you actually have to do that. I actually don't know, honestly speaking. But I can tell you the story of why we changed to SSPL.
Please, because you will be grilled, murdered / quartered afterwards. I'm joking.
That's okay. That's fine. Actually, what happened is MongoDB started out as with an AGPL license, which basically, in my understanding, says, hey, you can use the code however you like. However, if you offer it or if you modify it and offer it via like a network, then you have to open source like the components around it as well. And the idea for that was the following. So you have MongoDB, right? You have lots of people contributing, and all these people cost money. So you need some sort of commercial offering in order to finance that. And what happened back in the day is the cloud providers actually used a loophole in this AGPL license. Because the AGPL license only says if you take the product and you create a derivative of it and offer it via the network, then you have to open source all the stack that's behind it. So what they did is they just took the database as is, so they didn't modify it. And that was basically the loophole, right? This allowed them to basically offer MongoDB commercially without having to contribute anything. And this is the reason then why MongoDB later switched from AGPL to SPL. And in there, it basically says, of course, I'm not a lawyer, so the legal license there is leading, but it says, okay, you can use the community version for pretty much whatever you want, but you're not allowed to offer it as a cloud service unless you basically license or you pay like for it. So you make sure that if you use it commercially, you also contribute to its development. And this is basically the state of affairs ever since. So we're still on the SSPL license at the moment.
Interesting perspective again, because the reason why I brought this up in the first place, Redis, for want of a better database, recently changed their SSPL license back to a Affero GPL for that very same reason. And I'm just wondering, given that community change in terms of the licensing overhaul, why are you still sticking to SSPL if your competition actually does otherwise, as in the exact reverse?
Mm-hmm. It's an interesting perspective, an interesting thing to consider. I'm not aware of any discussions basically internally to change that. I think the main idea within MongoDB was to make the platform as open as possible. So we said, okay, we have to if we put some restrictions, okay, the restrictions should be as minimal as possible. Now, if we were to move back to an AGPL, that would mean that, okay, cloud providers would again be able to offer like the service without having to contribute to it. I think with Redis, as far as I know, this is already the case. I think there's some sort of Microsoft Redis version. So this is not offered by Redis itself, but like by Microsoft. So I think there the landscape is already a bit fragmented. Maybe that was the reason, but I can only speculate why they decided to move over. Maybe you have some insights there, why they specifically decided to move.
We have an episode on this.
Yes, we do. And full disclosure before the audience gets even confused more, Martin and myself used to work for Redis, so full disclosure, the following is not an ad. And no, Mr. What's his name again? Rowan Thorpe.
Salvatore? No,
the current CEO.
Oh, yeah. Okay.
Rowan Thorpe or something. If you're listening, the email address is sponsor@linuxinlaws.eu. I'm joking. But no, I mean, going back to much more safer grounds, the idea basically, and you shouldn't confuse the community edition or the open source version of Redis with the enterprise edition, because the enterprise edition actually is available as a managed service on Azure. You're absolutely right, yes. But the open source version that initially had a 3-clause BSD was changed to server-side public license quite a while ago. Earlier this year, as in 2025, past year, exactly, sorry. In 2025, it actually was changed back to a Faro GPL, meaning that any cloud provider who would use the codebase as such would also have to open source any components, because that's exactly what the Faro GPL refers to. Would have to open source any components that talk to the code base in terms of servers, instrumentation, orchestration components, essentially their cloud infrastructure software. Needless to say, that's exactly what the cloud providers will not do. Hence, this move, I think, was a pretty smart one, because that's exactly how you put a code base under an OSI compliant license without the hyperscalers being able to rein in the money in terms of to make profit from it. Because if they would do this, they would have to open source the entire infrastructure that talks to that code base.
Mm-hmm. I think, I mean, it's very interesting to, I'm not super firm on the details of all the licenses and so on, but I think this was also the original idea of Mongo, right? So we were initially exactly on this AGPL, and there was some sort of loophole that you could still somehow use. You could take like the tool as is without having to open source it. I think that was the main reason it was changed. It was changed over there. But I think I would need to look in detail into how all these licenses work and what precisely.
If you can't get sleep one night, we have an episode on licensing as well.
Yes, and maybe we should schedule another episode where you can bring in the lawyers or something. No, I'm joking. We won't do this. Okay, venturing back to much more safer grounds, just wondering, if I take a look at the Mongo website, I see a very familiar strain or slate or whatever you want to call it. With regards to positioning, Mongo apparently these days is entering the empty vector database space in terms of what can Mongo bring to the table with regards to large language models or artificial intelligence in general, when it comes down to not just training but also in inference, as in pushing vector functionality out to the AI masses. Funny enough, Redis and other competition is entering that space at a rapid pace as well. I mean, are you just one vector base of very many in terms of what makes it stand out from the competition? I'm just talking about the community edition now. I'm not talking about the enterprise kind of product as such. So what can MongoDB, or what differentiates between MongoDB, for want of a better explanation, from the rest of the vector database, NoSQL open source code bases out there, like, for example, Redis?
Mm-hmm. So basically, as a context, what are we currently doing? We currently have a vector search offering in our cloud offering. So this is our commercial offering. And what is currently in public preview is basically the vector search for community and also for the on-premise version. So this is currently in public preview. I'm not sure when it's going to be generally available, but eventually it will be. What is the idea behind this entire move? Well, we see that AI is really bringing massive productivity improvements. So every company I talk to, I mostly talk to banks and insurances. I really see that everybody is working on agents and on AI. And I see that this is going to bring really massive and material improvement when it comes to the internal processes. So I mostly see the benefit at the moment in the back office. processes. And so there is like lots of hype around AI, but like the potential benefit and efficiency gain, this is definitely real. So I've already seen projects going live and really bringing material benefit there. And this is why MongoDB overall is entering this space. I think MongoDB as a technology is fundamentally very well suited for these AI workloads. Because
can you, sorry to interrupt, can you allude a little bit more what type of use cases people are implementing with MongoDB for AI there?
Yeah, so what we see a lot is like those vector search use cases we see a lot in the insurance industry. So let's say you file like a claim, for example, then typically you have like a person sitting on the other side, and maybe there's some automation in the process, hopefully, but still quite a lot of things are still being done manual. And what we see at the moment is, or like what I see a lot, is that this whole idea of claims processing in the insurance space. So something happened, you write to your insurance, you snap a few photos and so on. And then it comes back to the insurance, and then there's a bunch of agents analyzing, whatever you have sent in. One agent is figuring out, okay, or what is the base data that you've submitted? What is your name, your first name, your last name, your insurance number? The next one is assessing the images you have seen and comparing it to claims that have already filed in the past, and also to check whether this is somewhat makes sense, right? Is the amount of damage that you say has happened, is that sort of reasonable? So this is something I see a lot. We also see it a lot in the health industry. So, for example, when you publish a new drug, there's lots of EU regulation. Like the bureaucracy is really a big hurdle there, and basically there's we have like lots of options to use Gen AI actually to reduce the bureaucracy there. So to reduce the manual labor you have to do, because you have to generate reports, and these reports have to conform to a specific template and so on. So all of that stuff is something you can do with Mongo. You can chat with PDFs. Yeah, you have some terms of services, some AGBs in the legal area. You can say, hey, what are the conditions? What does this thing say about the rent lease? Like how much lead time do I have to give until I can quit my rental contract? And then it will say, yeah, it's 3 months and 15 days, and you can find it on page 57, paragraph 3. So this is what I see primarily in the industry. And like the reason I think why MongoDB is very well suited for these types of workloads is because the premise of MongoDB is that, okay, the world is a messy place. Yeah, you can't fit data perfectly into tables. And if you think about these agentic systems, then these systems are very different from the systems that we have today. Because today what you do is you have some domain, you have some fixed rules, and then you implement those rules. But now with these agents, everything is much more open. Like the agent is looking at the data, it is creating a plan, it is then coming up with a plan and executing the plan using several tools. So you don't even know what exactly you're going to store in the first place. And this is basically what makes MongoDB really well suited for these AI applications, simply because the data is just so flexible that you store.
So do you mean storing vectors alongside the documents? Is that kind of
exactly? That is also one thing. So not only, in MongoDB, we have document model, right? And in the document, you can store whatever you want. You can store any key value pair. You can store coordinates. You can store like arrays and, anything you would like. And that also includes vectors. And then you can co-locate your vectors with the data that you have. And this has the advantage that you don't need a bolt-on solution, right? Because the main challenge is if you have separate systems, things are going to get slow, right? You need to keep them in sync. What happens if the sync fails? You need some sort of transactional logic between all of them. So these bolt-on solutions, they're pretty much suboptimal if you were running like in a very critical system. And this is what MongoDB can provide to you. So the idea is you store the data storing the data is as easy as, storing the object. You just take the object, you save it. And if you need some embeddings, if you want to have some AI functionality, no problem. You just say, hey, this field is like a vector. Go ahead, create a vector index, and then you search on it. As I said, for community currently in public preview, so everyone can try it out. And then I think eventually it will be rolled out to the main product.
Interesting perspective there, because if you take a look at the vector demands of typical large language models, they do not leave it at the gigabyte requirement scalability, but rather go into the terabyte realm. Mm-hmm. Just wondering in terms of what the base technology of the open source code base brings to the table with regards to horizontal and vertical scalability, because as we all know, if you stick to traditional von Neumann architectures or the Harvard stuff, scalability has a certain threshold where you actually can scale up a cluster only to a limited extent. Otherwise, you will run into performance issues. And if I take a look at ChatGPT version 5 and other technologies that are out there with regards to large language models, they need not just your ordinary vector database as in garden variety stuff, but rather something that is able to deliver at microsecond, nanosecond performance. Given the fact that persistence is not optional, like it is in Redis, how do you address these performance requirements, especially from a clustered use case perspective? Mm-hmm. This is getting a little bit technical now, but this is basically what you have to fulfill if you want to live up to that LLM dream.
Yeah, exactly. So a few things. So MongoDB in itself, like the AI offerings we have, like this more or less assumes that you use some LLM in the background if you use like a RAG applications. So we ourselves, we provide some embedding models. This is what we have. We have something called Voyage AI, but not something in the sense of ChatGPT. But to answer your question, how do you scale that? Well, as I said, this thing was originally built for like an ads use case. So what you can do is you can take the cluster and scale it horizontally. So you take the data and you distribute it over multiple machines. You partition your data and you scale it out. What's the advantage of that? Well, not only do you have your data over multiple machines now, but you can also scale your writes massively, because that's the biggest challenge with vertical scalability, right? If you always get a bigger box, as you said, at some point you have the biggest box. So what do you do then, right? And then in that case, the horizontal scalability of Mongo comes in, where you can say, hey, I just chart a cluster, and then you can really go planet scale. So I'm not aware that MongoDB is used as the backend for some, large language model that is as large of like ChatGPT or so. But overall, like the scalability from the core technology is definitely possible. Yeah.
Can you shard your vector indexes as well then?
Well, I mean, what you do is you pick like a shard key, and then the database is going to distribute the data over multiple machines.
Yeah, not the data itself, but the let's say the vector index, right?
Exactly. And then for this particular partition that you have on the machine, for that you build the vector index. So yes, on each.
Martin, we should probably explain for the non-technical users in the audience what a vector index is and why this is important, before the remaining two members of the audience fall asleep fast.
Okay, I mean, I can give it a shot. So basically,
Martin can take that too. I'm just wondering. Like, that's all.
Martin, we should I guess it makes more sense. Really. That's why he's here.
Okay, that's fine. No, so the idea of AI, or like the idea of vector search that we have today, is all based around the idea of vectors. So when we're talking about vectors, we're always talking about something in the realm of similarity search. And the way this works is you have some concept, some text, maybe some audio or so. And what you do is you run this thing through a big black box. This black box is called an embedding model. And then once you run that through an embedding model, it spits out a vector. So you can really think of a vector just like in school, right? A vector is essentially just an array, a list of numbers. which represents like just some point in a vector space. Typically, the space has like lots of dimensions, and with the larger models, we see 2048. Some are even larger right now, dimensions. And what a vector embedding does is it puts points that are similar in terms of meaning close to each other. So let's say you have cat, you have the word cat, and you have the word tiger. Okay, those are kind of similar. They're both cats in some way, right? So an embedding model would take those words and would give them like different vectors. Those vectors would be rather close to each other. So concepts that are related are basically close to each other in the vector space. Concepts that are not related are far apart in the vector space.
Also known as vector similarity, exactly.
Exactly. And this is basically the whole idea of AI and all the workloads that you see these days, right? So we talked about this insurance use case. In that case, you would basically say, hey, I want you to give me like claims that are similar in terms of what happened. And because you ran all the data through an embedding model, it will then say, hey, I found 5,000 claims that are similar to the one you had, and the average damage amount was that so and so high. So this is basically the AI part and the magic part of it, I would say. And this can enable completely new applications, actually, and completely new workloads.
Interesting perspective, but leaving the fad of AI in general and large language models in particular, because we are talking about a fad, because at the end of the day, AI will be a commodity in a couple of years, similar to clouds that have mastered the hype cycle in terms of nobody talks about it anymore. What's next for MongoDB once this fad with regards to AI and large language models and also vector database functionality has died down, which will very soon anyway? So what's next?
That is a very good and very strategic question. So, I mean, what I can tell you what I think is going to be next in the AI space. What is going to come after AI? That's very hard to tell. I think we haven't reached the full potential of it yet. You're right; it will become a commodity, but I'm also convinced that the use cases that we will be able to do will be much more sophisticated in a bunch of years. Initially, when ChatGPT came out, everybody was like, "Oh wow, this is the coolest thing I've ever seen," right? And then we started with RAG applications. So retrieval or augmented generation. So this is the thing that basically uses an internal knowledge base, fetches like some data from it, and then uses an LLM to answer your questions. So you can, let's say you ask HR chatbot within your company. That could be like a RAG application. And now we're moving to the agentic application. So
like
I don't
things that hallucinate even more than the current ones.
that is actually the challenge. You're totally right. And the thing is, with all these applications is, a lot of providers like provide vector search and, the ability to do AI workloads. But the question is always, how much does it hallucinate and how well does it work? And in order to make that kind of stuff work, you need additional components in your stack. You need re-rankers to just get like better and more fine-grained results. So this is something that we also incorporate in our stack. So this is next. This is basically are the next things that are going to come.
These are called humans, no? I come back.
Yeah.
So yeah, in terms of what comes next, you've heard of Skynet, right? So that's...
Yeah. I mean, that's also an interesting philosophical discussion, right? Where does this lead?
Do you provide Skynet? Do you provide Skynet APIs? I'm just wondering, like.
Not yet.
It should be the next thing, really, shouldn't it?
So why don't we get product management on the show for the next time around, just in case? No, I'm joking.
That would be
Skynet. If you're listening, the email address is sponsor@linux.eu.
I mean, if they're listening, of course they're listening.
I mean, if you look at it really long term, or I mean, it's not specific to MongoDB, but long term, I think what's going to happen is the following. I think this AI thing, we're going to get better and more sophisticated in the future. I think we haven't fully reached the entire potential of it yet. We are far from it. Technically speaking, a lot of things are possible, but the industry adoption is not as fast as one might imagine. So I think this topic is going to be present for like quite a few years to come. Then once these AI systems have actually reached a certain level of sophistication, what is the next step? The next step would be you have such a smart AI that you can put it in some sort of body, like in some sort of robot or something. And I think that's probably how the future is going to look like.
These are here already, by the way. I think Chris has a few of those at home.
Yeah,
of the female variety.
Changing the subject just a tad. So if you're talking about a sapient AI, how can MongoDB with its vector search capabilities contribute to that? No, I'm joking. In my books, we are far away from a sapient version of anything that is even close to something called intelligence. So rest assured, Skynet has a long way to go, in my books anyway. And if I even take a look at the commercial offerings, like the commercial versions of ChatGPT, Copilot, Gemini, Perplexity, and all the rest of them, a long way to go in terms of even if you get the prompting right, they do hallucinate a lot. And if current market echoes anything to go by, the road is really long, and the sapient AI is not even on the remote horizon in my books anyway. Given the fact that this is a philosophical discussion and we only have about 3 hours left, before we close this off, why don't we change tack a little bit? There are two pressing questions actually from a technical perspective that I still have to ask, because otherwise the audience probably will kill me. Why JavaScript as the server-side programming language, and why Bazel as the main building system? Because this is ancient.
So I would say JavaScript because it's just so popular.
Sorry, says who?
Says the internet.
GOB ranks it on position number 9, even I think before. The importance of being earnest. Links will, of course, we will show notes. The most popular programming language on the internet in terms of Stack Overflow as well as GOB is actually Python.
Yeah. So I think JavaScript is always very big, right?
Yeah, I think the JavaScript comes from its origins, right? As a advert.
That's legacy. I see. Very good.
I would much rather say flexibility. So I would say probably the reason why JavaScript was like one of the first supported languages is, because of this very idea of
on the server side.
Yeah.
I mean, the server side is performance, no? And I would see JavaScript at the very top of that list. So this is just playing the devil's advocate here, but because, I mean, if you take a look at any JavaScript implementation out there in the market, performance not the very top of the list. And if you're talking about server-side code execution, microseconds, nanoseconds do count.
It depends on what use case you're talking about. I think initially the idea to extensively support JavaScript is because, as I said, popularity, and also the other idea is that it's just a dynamic language, right? So MongoDB has this idea that you can put different things into the database, things that have different structure, and that just works really well with JavaScript. Also works well with Python and with any other dynamically typed language. But I think that's pretty much the main reason, I would say.
And why Bazel as the main build system, if I may be so cocky?
That is a very good question. I actually don't have an answer for that.
Okay, fair enough. I mean, people, if you go to the GitHub repo, you see actually a Bazel subdirectory with regards to build instructions. And I mean, it's a build system that is ancient, but it's still being used in certain part of the industry. I'm just wondering, like, why. I mean, other people use Mason, Ninja, whatever, as in the hipsters, but I reckon MongoDB wouldn't be considered to be a hipster database, or maybe I'm wrong. I don't know. Maybe Jan has a different perspective on this.
Yeah, I think probably the reason it hasn't been changed so far is because it works. I think that was probably the main reason. I don't know if if Bazel has always been there from the very get-go.
So do autoconf tools and makefiles.
Indeed.
But you're talking about 30 years back. I don't know. Anyway,
Indeed.
before this is getting even more philosophical, Martin, any closing questions before we go to the boxes?
No, that's been very interesting and enlightening. Thank you.
That has been more than interesting, exactly. So, what is your POX, Jan, as in the pick of the week?
Okay. What interesting things have I seen like this week?
Or the week before, depending.
Or the week before.
Or the month before, or the year before, or the decade before. But the POX actually refers to a short amount of time, actually.
Yeah, I actually can't tell you like a specific thing that
Anything goes.
In the tech and database.
No, anything.
So far.
Anything. Your favorite recipe, your mom's favorite jam, whatever that you sampled.
My mom's favorite jam. Well, I actually got home the other day, and my mom and my dad are actually very much into making these jams because we have like large fruit, like lots of trees with fruits and so on. That was definitely my pick of the day because I think there's no better jam than the jam you make yourself. So now that you mentioned jam, that's actually a good example. But yeah, that's pretty much my pick of the week, I'd say.
Okay, Martin, over to you.
Yeah, my pick of the week is a television series called SEAL Team.
Again?
Excellent. It is. It's my relaxation time at the end of the day is watch a bit of telly. So, yeah.
The name again is, sorry?
The name is SEAL Team. It's just
TLT Mitzvah.
You what?
Team.
SEAL Team. SEAL, as in Navy SEAL. Anyway.
Navy. Okay.
Okay.
So yeah, it's just a bit of drama, quite light entertainment. A few people get blown up, that kind of stuff. So
okay.
Quite amusing.
It's military related, I take it.
Yes, indeed. That's what
as usual. Okay, fair enough. Fair enough. Just wondering. Okay, my POX of the week, not too far away, is actually a miniseries of 2 movies by the names of Radcliffe 1 and 2, done by John Woo, if that still rings a bell. Quite a famous director back in the 90s, 80s, maybe zeros. But if you're into ancient Chinese warfare, these are 2 films that you do not want to miss. Won't give away too much. The photography is just amazing. And if you are so inclined, make sure that you watch the Chinese original because the dubbed version just is not that great, let's put it this way. And with that, Jan, I would like to thank you for your time.
Yeah, thank you very much.
Thank you so much,
and
guys.
Looking forward to having you on the show in the near future to give a serious update on quantum computing, the thing that came next after RAGs, large language
Skynet
models.
APIs, yeah.
Exactly, that sort of thing.
APIs, yeah.
Exactly. And with that, thank you for listening. This is the Linux In-Laws.
You come for the knowledge.
But stay for the madness.
Thank you for listening.
We hope you liked this feature presentation. If so, please spread the word. If not, please let us know. Feedback at linuxinlaws.eu.